So adding and subtracting polynomials. We're going to start off with an example where we're going to add these two polynomials, but we're going to use algebra tiles, okay? So we're going to kind of draw this out to get the idea of how this whole process works. So we're going to add 2x squared plus 5x minus 3. So we have a trinomial plus another trinomial. Okay, so let's make out 2x squared here. So if you remember, that would be x squared would be two larger squares. Oops. And they're positive. So I'm just going to color coordinate this x squared. There we go. There's 2x squared. Then we want to do 5x plus 5x. Okay? Yes, those are the bars, they call them. Kind of like rectangles. And we want 5 of them. 1, 2, 3, 4, and 5. Okay? And so I'm going to do those again. They're positive, so I'll just put x, 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 and x. Okay? So I've got 2x squared plus 5x, and then minus 3. So I'm going to do 3 of these unit tiles. But those are going to be negative. Yeah. So that's, to make it minus 3, we'll do 3 this way. Okay. So there you have it. 2x squared plus 5x minus 3. All right. And we're going to add to that x squared minus 2x plus 1. So let's make that. We'll do x squared. So that's going to be another x squared. There it is. And then what we want is minus 2x. So let's make, 2 of those minus bars. Yeah. So this time maybe I'll do those in red for negative, just like I did for the previous one. There we go. Minus x, and plus 1, so 1 positive. Put a little plus on this one. Okay, so x squared minus 2x plus 1. Okay. Yeah. It's like combining the like terms. So we have 2x squared and then another x squared. Yes. You can cancel out a negative with a positive, negative with a positive. So that's 3x. So plus 3x, it's positive. And we could do the same thing here. All right. So record the sum of the polynomial. We just recorded the sum of the polynomial. 3x squared plus 3x minus 2. All right. So it asks us to describe the steps. Let's just go ahead and record this answer here again. Let's just record that answer again right there. So how would we describe the steps? What did we do? Okay, so you made the algebra tiles. Definitely did that. So we made the algebra tiles. I like that. Combine the like terms. And pretty much that's what we did, right? Combine the like terms, we got 3x squared. Combine the like terms with the x tiles, got 3x. Combine the unit tiles, got minus 2. And then just wrote the answer. All right. All right. Let's try to think here. Think of an advantage and a disadvantage of the algebra tiles. Yes. Yeah, because it's visual, right? If you're a visual, it's visual, so that's an advantage. It's visual. What's a disadvantage? Tedious. Unnecessary. Okay. Let's go with tedious. Takes a while. Yeah, it's not the desired way to do this, but it kind of proves the point. It shows us how moving forward how we're going to do this. Okay. Pretty much it's combining like terms. Okay. We're going to identify the terms by their exponents and by their variables and their exponents. Combine them, and then we'll do constants together as well. Okay. So when you're adding polynomials, a polynomial can be added by identifying the like terms and adding the coefficients. All right. Describe how to identify like terms in the space below. What are we going to look for when we want like terms? Look for the same variable and exponent. Oh, sorry about that. So we're going to look for the same variable and exponent. All right. So there's two methods we can use. One is definitely more popular than the other, but either one's going to work, and neither one involves redrawing algebra tiles. It's the horizontal or the vertical method, and whichever one you like, you can use. I'll just show you both. But I'll tell you, by far, the horizontal method is more popular, I think, because it takes up less space. Okay? So let's go ahead and do this method. You guys ready? So here's the horizontal method. It involves identifying the like terms. So let's identify the like terms. Starting with, what do we have? 5x squared plus 4x minus 7. And we're going to add negative 2x plus 3x minus 11. Okay? So we have 5x squared, right? Negative 2x squared. So let's just write those here. 5x squared minus 2x squared. Okay. Then we would do 4x and 3x. Let's put those over here. Okay, and finally the constants, which are minus 7 and minus 11. Okay, so you see we just grouped them by like terms. And so let's see what we get. Remember, we just combine the coefficients. 5 take away 2. 3x to the second. We're not touching the exponent or the variable at all. That will only happen when we multiply or divide. Okay? So here we got 4x plus 3x, that's 7x minus 18. So there's our answer, 3x squared plus 7x minus 18. Okay? Huh? That's our answer. Now, let's try this with the vertical method. So the vertical method is, remember in elementary school when you were doing like 3, 4, or 5-digit numbers and you would stack them one on top of the other by place value, the ones place, the tens place, the... Yes. We're going to stack these. So we could do 5x squared plus 4x, take away 7, and then negative 2x squared plus 3x minus 11. You kind of stack them by the terms. You line up the terms, x squared terms, x terms, and constant terms. Okay? And then you get the same answer. In fact, you can go right to left, left to right. So this would be still 3x squared. 4 and 3 makes 7x. Minus 7 and minus 11 is minus 18. Okay? Now, let me just say this, though. When I'm doing this part right here in the middle for the horizontal method, this here, I do that in my head basically, and I'm sure that's what you're going to do. Right? You see, okay, I got 5, negative 2, they're both x squared. You got 3x squared. 4 and 3x, 7x. Minus 7, minus 11, minus 18. So a lot of this can be done mentally. Okay? But that's basically how we do that. So go ahead and, which method of adding polynomials do you prefer? I'll let you pick. Personally, I like horizontal method. And why? Quick and easy. At least for me. Okay. So using your preferred method, if you want to do vertical method, you could just show the work over here. Go ahead and add these two polynomials. Negative 8x squared minus 6x plus 11. Add that with negative x squared plus 9x minus 7. Yeah. So I'm going to get negative 9x squared plus 3x minus 6. So basically, all we're doing is extending what we did when we were just combining like terms last semester to this semester with polynomials. All right? Any questions? Okay, I do see a couple people still looking over. Can we flip this over and do the back part? Let's do it. All right, let's talk about subtracting polynomials now. All right. So just like anything we've done so far, when it comes to subtracting, we're going to do inverse addition. We're going to add the opposite. Okay, guys. Subtraction is the same as adding the inverse or opposite. For example, 15 take away 7 can be written as 15 plus negative 7. Okay. We're going to do the same thing with this method. So when subtracting polynomials, write the problem as an addition problem by adding the opposite of each term and in the second polynomial. Yeah. So opposite goes here.
Why can't you just make it plus minus? Because then negative would be the
Plus minus?
Like plus negative and then the parentheses 10x, because then you can just distribute the
Yeah. Well, let me show you how this works or how we do it. It says practice rewrite each subtraction problem as an addition problem. We're not going to solve it. Basically, it's distributing the minus. We've done this before. Remember when we did this? So it would be, for example, 8x. It's keep change opposite. Keep it, change it. Oh, I see what you mean. That's so if we want to, you could do plus minus. I'm going to just keep it as a minus. Negative times this is minus 10x. And negative times negative is plus 6. That's usually how I do it. And I would do the same thing here. I'm going to distribute that minus to each term. So each of these gets the sign flipped. So the first term stays the same, or the first polynomial, negative 4x squared plus x minus 3. And then now we're going to have plus 5x squared minus 9x plus 11. And then you would do an polynomial addition. Okay. Any questions? All right, so let's go ahead and do a few of these. We're going to do some subtraction, addition, a little of everything. You guys ready? Okay. So use what you've learned and find the sum or difference of each polynomial. Okay. I'm a big fan of horizontal method. So I'm just going to distribute this minus sign here. So I've got 3x squared plus 9x, take away 1, and then that's going to be plus 4x squared minus 8x plus 6. And then I'm just going to find the like terms and combine them. Okay, so I'm going to start with these guys. And then plus x. Now I'm going to be combining 9x and minus 8x. So that's 1x. So I'll just write that as x plus x. And then I've got negative 1 and positive 6. So that's 5. So plus 5. Okay. Not too bad. Let's do the next one. I'm going to distribute my minus. Oh, this is a little scrambled up. So I'm going to write it in standard form. This first one's not in standard form. It just bugs me. So I'm going to write negative 3x squared plus 2x plus 12 minus 9x squared plus, actually minus. If I'm writing these in standard form, what comes next?
4.
Yeah, 4. But it's minus, right? Negative times a positive is minus 4x. And then negative times a negative is plus 8. So now both of them are in standard form. And I could just combine the like terms, starting with the x squared terms. This is called the quadratic terms, by the way. Remember, things that are squared are quadratic. So we had the quadratic terms, negative 12, and then we're going to combine the linear terms. The terms that have just a single variable with no exponent, those are called the linear terms. And then minus 2x. And then 12 and 8 is going to give us 20. Okay. All right. So the next one has a little of everything. Let's just see what we got. So here, we don't have to combine anything, right? So I'm just going to write that 4x squared, just bring it down. I'm going to bring these out of the parentheses. We don't have to distribute anything, guys. So I'm going to bring down minus 3x squared plus 5. And then we do have to distribute the minus here. So it's going to be minus 8x minus 4. Okay, let's find our like terms. Let's start with x squareds. 4x squared minus 3x squared. What do we get? 1x squared. So I'll just write it as x squared. And then I want the linear term, so we'll combine. Well, we just have one. We just have one, right? Oh, it was 5x. Ooh. We have two of them now. Thank you for catching that. I just put a 5. It should have been 5x. So now what's 5 take away 3? 5 take away 8. Minus 3x minus 4. I forgot to put that x. It's a little ugly, yeah. But we don't have to subtract, right? All right. Well, let's see. 1/5 x squared. Luckily, it looks like we have somewhat of plus 2/3 x. Take away 8. We at least have some common denominators going on here. We don't have to distribute a minus, so it's plus 3/5 x squared plus 9. Okay. We do have to combine this. 1/5 with 3/5. 4/5. 4/5. It's just 4/5 x squared. It's a coefficient. Okay, then we have to combine. For the linear term, do we have to combine it with anything? Oh, good. So that one's just by its lonesome, 2/3 x. So plus 2/3 x. And then 8, minus 8 and plus 9 is 1. Okay, not too bad. Okay. Let's move on to the last two. Katie simplified the expression as shown. Describe Katie's error and find the correct simplified expression. Okay, let's see what she did. Did she distribute correctly? That's usually the mistake. This was good. Right here. And right here. Right. So it looks like she distributed the negative to the first term, and that's it. So how would we describe that mistake?
Forgot to multiply minus or next and
Yeah. Yep. Forgot to distribute minus, I'll put that in quotations, to minus 7x and plus 9. Okay, let's fix it then. Let's distribute it correctly. So 7x squared plus 8x squared plus 7x minus 9. And that's going to give us 15. Is it going to be 15x squared? 15x squared
plus 7x
minus 9. There's our answer. Okay. And finally, Matt's rectangular patio has a total area of 12x squared minus 15x plus 1. So that whole area, right? The outdoor rug, represented by the white rectangle, has an area of 8x squared plus 2x minus 4. Write an expression to represent the area in gray region, the area not covered by the rug. So we just want yeah, it involves subtraction, right? So we're throwing in a little geometry. We have an expression for the whole area. We have an expression for the white rug. We have to remove the rug, subtract it from the whole area, which means subtract 8x squared plus 2x minus 4 from the first polynomial. So let's do it. Let's set it up first of all. We're going to do this 12x squared minus 5x plus 1. We're going to subtract the area of the rug, which is 8x squared plus 2x minus 4. Let's distribute the minus sign. So yeah, you have to take away the rug to get the region that's the border. Minus 8x squared minus 2x plus 4. By the way, if some of you take geometry next year, you'll be doing a lot of this kind of stuff. Okay, let's just figure it out. 12 take away 8 is 4x squared. Negative 5x, negative 2x is negative 7x. 1 and 4 makes 5. So this is the expression for the white rug. There it is. All right, and that are the notes. Those are the notes.
Isn't that the gray area, not the blue area?
Oh, yes. Fix it. Okay. It's Yeah. Yeah. Okay, it's the border region. Sorry about that.